Hello students, today we learned the transformation of coordinate system with example. In the last lecture we have discussing about the transformation of Cartesian coordinate system to the cylindrical coordinate system. The cylindrical coordinate system, and we have also seen the one example. In this lecture we have discussing the transformation of Cartesian coordinate system to the spherical coordinate system. Suppose you have the given one point PA, which is the x, y and z, and you transform it in the r, theta and phi, means in the spherical coordinate system. Then using this formula you can transform the point to the vice versa, means you can transform if you have the given Cartesian coordinate system point to the spherical. Similarly, if you have given the spherical coordinate system point, then you can transform to the Cartesian coordinate system. Now, when you are doing the transformation of vector from one coordinate system to the another coordinate system, suppose you have given the one vector A, which is the represented by the ax plus ay plus az direction, and you transform this vector to the spherical coordinate system, means in general ar in ar direction plus a theta in a theta direction plus a phi in a phi direction. Then you, during the transformation the vector, we required the put the value of dot product between the unit vector. Suppose we can say the x dot ar, then you require to put the value of them using this table, and this value is the sin theta cos phi. Same, you require to put the value of ax dot a theta, ax dot a phi, ay dot ar, ay dot a theta, ay dot a phi, and az dot ar, az dot a theta and az dot a phi. So this formula and this table are the very most important for the example of the transformation of Cartesian coordinate system to the spherical coordinate system, and I advise to remember these formulas and the tables. Okay, example, here we require to transform the vectors to the spherical coordinate systems. Here we have the given vector in the Cartesian coordinate system in all the options, and in the A we have the given point in spherical coordinate system. In the B we have the given point in Cartesian coordinate system, and in C we have the given point in again in the Cartesian coordinate system. So in the first we just required to transform the vector and put the value of the point. In the B and C, first of all we transform the point from Cartesian to the spherical, and then put the value of the point to the find vector of Cartesian spherical coordinate system, or we can say the transform vector of the spherical coordinate system. Okay, let's start with the A. Okay, here we have given the vector A, which is the phi ax, and we require to transform this vector to the spherical coordinate system, means in ax a r in a r direction plus a theta in a theta direction plus a phi in a phi direction. Now here if we have the ar component, a theta component and a phi component, then by putting the value of ar, a theta and a phi, we get our final answer. So first of all we find the ar component of the spherical coordinate. For that there is a simple formula from which vector we have to find. So first of all here we have to find the from a vector, and here which component we have to find. So here we have to find the component ar. So dot product of the vector with the finding component. So ar, the value of the a vector is phi ax dot AR. Now here we use the table, transformation table. So Ax dot AR means sin theta cos phi. So put the value of that phi is equal to sin theta dot cos phi. Similarly, if we require to find the A theta, then we can say that vector A itself dot unit vector of the finding component. So here phi Ax dot A theta. Again we use the transformation table. So Ax dot A theta gives the cos theta cos phi. So we put the value of cos theta, phi cos theta cos phi. And for the A phi component, again A vector dot A phi, and that's value is the phi Ax dot A phi, and the value of Ax dot A phi can be, again we find them from the transformation table, and it is the minus sin phi. So let's put the value minus sin phi. Let's first verify phi. Yeah, okay. So here we get the three component, AR component, A theta component, and A phi component. Put this value to the general vector, we get phi sin theta cos phi in AR direction plus phi cos theta cos phi in A theta direction plus minus phi sin phi in A phi direction. Now from point we put the value of theta, phi, and phi, and here we have the given point is r is equal to 4, theta is equal to 25, and phi is equal to 120, means theta is 25, and phi is 120 degree. Let's put this value. We get phi sin theta is 25 degree and cos phi is 120 degree in AR direction plus phi cos theta is 25 degree and cos phi means 120 degree in A theta direction minus phi sin phi means 120 degree in A phi direction. If we put the value and evaluate them, we get the answer minus 1.055 in AR direction plus minus 2.265 in A theta direction minus 4.33 in A phi direction. This is our final vector in spherical coordinate system at point B. Okay, now in the example in B, we require to find the spherical coordinate system at point x is equal to 2, y is equal to 3, and z is equal to minus 1. Here point is given in the Cartesian coordinate system and the vector is also given in the Cartesian coordinate system. So first of all we find out the point in the spherical coordinate system. using the formula, and then after put the value of theta is equal to 20, theta and the phi in the transform vector. So we find the B here. Here we have given the point A, which is the 2, 3 and minus 1, x, y and z. So first of all transform this point into the r, theta and phi. For the r, we know that it is the under root x square plus y square plus z square. So we can say that under root 4 plus 9 plus 1, so we get 3.742. For the theta, we have the cos inverse z by r. So cos inverse z is the minus 1 and r is the 3.742. If we evaluate, we get the 105.5 degree, and for the phi we can say that tan inverse y by x. So tan inverse, here y is 3 and x is 2. If we evaluate, then we get 56.3 degree. Now in the A section, we already transformed the vector phi ax in the Cartesian coordinate system. Means here we already transformed this vector into the spherical coordinate system, and this vector is the here. So we directly put our transform point to this equation. So we get vector A is equal to phi sin theta cos phi in arrow direction plus phi cos theta cos phi in a theta direction minus phi sin phi in a phi direction. So if we put the value of theta and phi here, we get phi sin theta is 105.5 degree cos 56.3 degree in arrow direction plus phi cos 105.5 degree cos phi 56.3 degree in a theta direction minus phi sin 56.3 degree in a phi direction. If we evaluate it by putting the value of sine and cos, we get the final answer is 2.673 in AR direction minus 0.741 a theta direction minus 4.160 in a phi direction. This is our final vector in the spherical coordinate system at point A, which is the 2, 3 and minus 1. Okay, thank you.